So we saw we could add, subtract, play around. So what if, poof, I turned it into a crazy looking equation with some unknown X matrix in there? Could we figure out what it is? Very likely we can. So let's take a look at it. I've got 2 times my unknown plus the matrix A is equal to the matrix B. I can solve that little equation for X just on my own. So there's no matrix multiplication to try to undo here. So starting from there, I'm going to minus A. So now I would have 2 times whatever X is the same as whatever B minus A is. Then to figure out just what X is, this is doubled. So I have to have the result. I have to divide all the entries by 2 in order to get what X is. I'm going to figure out B minus A first, and then we'll do the divide by 2 steps. So let's take that to the side. B 2, 6, negative 1, 5 minus A 4, negative 3, 1, 11. Now, if you wrote negative A plus B, you'd do negative 1 times A and then add the B entries to it. It's still going to work out. All right, so B minus A, 2 minus 4 is, I'm going to go ahead and fill this in under B minus A, negative 2. Negative 1 minus negative 3 plus positive is now a 2. 6 minus 1 is 5. 5 minus 11 is negative 6. So there's our B minus A. And this is equivalent to 2x's. So in order to get rid of the 2, like if it was a normal equation, just 2 times a normal x, I'd divide by 2. With matrices, we don't like writing divide by, like matrix division is no. Not the way we talk about it, basically. So instead, I'm going to multiply both sides by the scalar 1/2. And that 1/2 will cancel out the 2 on the left and give us our result on the right. Now, traditionally, we write scalars in front of the matrix. So that's why I'm squeezing it in there instead of writing it on the other side, because matrices don't always commute with all the operations. So we're usually very particular about which side to write it on. So here is our x. And I'm just going to divide each of the entries by 2 or multiply them by 1/2. So now it's negative 1, positive 1, 5/2, and negative 3. So this is what the matrix X must be for that equation to be true with the given A and B. Now for this to work, A and B, because we had to add or subtract them, they had to be the same dimensions, and X came out to be the same dimensions as well. So in order for these kind of basic matrix equations to work, the dimensions have to match across the board. Same number of rows, same number of columns. Now, what we're going to see with multiplying, though, is we do have to have numbers the same, but it's not looking the same the way it is here. We get kind of a weird flip-flop. So I'm going to stop it, and then we will start that.